Assalamualaikum, my name is Yasmin Irdina, and I'll start with our group video demonstration with project background. First of all, I'll talk about the current practice of smart hydroponic system in HYDROPONIC Shah Alam. So the current practice, the first one is the absence of water level detection. They use timer for water level detection. So what's the problem with this is the potential for underwatering. So the timer-based system may fail to detect when the water level is too low, which can risk the plant health. So our proposed idea for our prototype is to use water level detection using. The third current practice is the absence of temperature sensor. So the problem with this current practice is the extreme and high temperature condition. So it can stress the plant, which can reduce the growth rates, wilting, and even lead to plant deaths. So it can also increase evaporation rates, which leads to increasing water loss. So since we use timer as our water level detection, so this will affect the whole prototype. So our proposed prototype is to use temperature detection using temperature sensor, the SP1820 with adapter. So the last one is the LEX database and web application interface. The problem with this is limits effective monitoring and control of sensor. So it can impact the ability to determine, to optimize the resource utilization, and it cannot improve overall efficiency. So our proposal is to use the same database with web application interface.
Assalamualaikum. My name is Nurwaheeda, Binti Mohamad. Now I will explain about our project's problem statement. So for the first one, the traditional method of determining whether a plant is ready for harvest is often manual and time-consuming. This method is not always accurate and can lead to premature or late harvesting, affecting the quality and quantity of the produce. The second problem statement is the challenge lies in relying on a timer-based system to maintain water levels in the hydroponic setup, which may result in inefficient water usage and potential overwatering or underwatering issues. The third one is the absence of a temperature sensor in the previous hydroponic project resulted in a lack of real-time monitoring and control over water temperature, potentially leading to suboptimal growing conditions and increased risk of plant health issues.
Hi and Assalamualaikum, my name is Rusydina and Puteri. So today I will talk about system design. So the ESP32 will power up and configure all the serious interface for the water level sensor, temperature sensor, infrared sensor and also the water pump. The water level sensor is used to measure the water level in the reservoir and transmit it to the ESP32. When the ESP32 analyzes the data received from the water level sensor, if the water level is below a certain data, which is we set it as 50 millimeters, the system will trigger the water pump to pump the water into the reservoir until the water sensor show a predetermined water level in the reservoir. Temperature sensor detects the water temperature and pass the information to the ESP32. The ESP32 will analyze the data received from the temperature sensor, and when the water temperature is more beyond the certain threshold, which is we set it as 35 degrees Celsius, the ESP32 will generate a signal to switch on the water pump. This can circulate the water temperature so that it can maintain ideal temperature for the plant. Next, for the infrared sensor, it measures the height of the plant and sends the data to the ESP32, which ESP32 can process the height data from the IR sensor to determine if the plant reached optimal height for their harvest. Message in the interface can show that it's ready to harvest, and this information can be received online using a connected interface, for instance, XAMPP, for a live session monitoring.
Okay, for significance, firstly, pressures and control. Hydroponic system enable pressures control of growing conditions like water level, temperatures, and plant height. Enhance the plant growth and resource use. This aligns with your IOT system goals for pressures monitoring and automatizations in hydroponic farming. Second, data-driven decision making. By using XAMPP-based data management tools in our hydroponic system, allow efficient data handling and monitoring. This data-driven improve decision making efficiency and sustainability, supporting our objective of data management and interface for the IoT system.